Thanks for coming for the part 2 video. In this video I will show you how I made this box to enclose all the boards. I'm taking 3D printer filament of carbon fiber PLA and white filament for letterings. You can see this is white filament. Let's install these filaments into the Bamboo Lab X1 carbon 3D printer. This AMS box is very easy for us to have 4 filament spools in a single box, which is also avoiding humidity, which will make the filaments to be brittle. The printer components you can see here. Let me take it out from the printer. Let's take their parts from the bed. I like this thing because the bed is flexible here. You just have to make this bed kind of bending. You will get the parts outside. You can see here the letterings are in white. It means it's a dual color printing. You can see some supports also. Now I need to remove all the supports and from the bed. Now I will remove these supports using a normal wire crimping tool. You can use any tools to remove this, it's not a problem. And finally, don't forget to chamfer all these edges with a chamfering tool. You can remove all the inside supports as well before we go to chamfer. It's a usual practice to use adhesive in the bed before printing to make sure the first layer of the printing is good in adhesion with the bed. But it forms a white layer on the printed parts. You can remove those white marks by adding a normal water, scrub it and wipe it out. Let's assemble all the boards as per the mounting provisions provided inside the box. Yeah, let me check all the positions are matching. Yes, it's correctly matching now. You can assemble it inside them. Now the design looks good, but the problem is when I try to assemble the potentiometer, a complete layer broken out, and I added some epoxy clear coat, but it doesn't work. You can see the components got separated. The layers are not so rigid because the thickness of this is very less. And for the top door assembly, I provided two protrusions which will have some kind of interference weight, but still I have a problem in sliding in up and down. Now it's a complete waste. We'll throw it and we'll improvise the design. Let's start with the rectangular box. All I need to make here is I have to make sure that all these boards, Arduino Uno and DRB8825 driver and extension board, should be inside this box. And in addition to these boards, I also need to add the potentiometer inside and 12 volt connector for giving the power supply in. So let's make an extrusion. I already made this model, but for the video purpose I am making it a more detailed explanatory video. I made a shell of 4 mm thickness, so now we can place the components in this portion. So this hole I will use it for my 12 volt connector for DC supply input. This is of 12 mm diameter, and this hole I will use for my potentiometer to assemble. Basically the potentiometer will have a threaded portion, and you have a nut outside. You have to insert through this hole and assemble the nut from the outside. I made some protrusion here to make some rigid strength support here for Arduino board connector. Let's see how it looks later. I made a good chamfer here to make sure that it is not disturbing the potentiometer. And later this pocket I made for ensuring that Arduino's USB port for connecting to the PC should be visible outside. And I added some chamfers here to make sure that there is no problem while connecting and disconnecting the PC cable. I added rounds inside to make the printing easier, and also outside for avoiding the sharp edges. I added this engraving, embossing or protrusion to make sure that the lettering and the connection identities are defined. Here I have given USB PC, and it is pot, means potentiometer of 10K. This is 12 volt DC supply in. Obviously I need to provide some base stand to make sure this box is not falling away or not having any uneven surfaces. Added some round edges outside to make sure the box is not so sharp edged. Yeah. Here's the main part. The thing is, here I need to assemble the DRV8825 driver and its extension board, but I'm gonna use only these protrusions to assemble, not any threaded holes, threaded studs, nothing else. I made some draft here, so the board will come and assemble in this up to here, and it cannot go up to the bottom. So you must be having 5 mm clearance from the bottom, and even though if it touches the ground there is no problem because it is a plastic body we are going to make. So, and I'm not going to give more concentration on this mounting parts using the threaded holes. I'll use this type of drafted cones to assemble them. Yes, so I plan for making this box with magnetic locking. So in order to give more support for this corner edges, I've added this type of a cylindrical arrangements on 4 corners, as you see here. Later I will add a pocket for assembling the magnets. So these pockets of a 10.2 mm diameter will incorporate the magnets while printing, and then I have to close them, otherwise the magnet will be visible outside, which is not okay for me. I don't want the magnets to be exposed outside, so I closed it with another extrusion. So while printing I will show in a cross section what will happen. Let's zoom in this part. So while printing, I know what is the layer number for this portion, this surface. I will stop the printing and then I will assemble this magnet, and then I will restart the print, resume the print, to be frank. Then the layers will be formed over the magnet and there will not be any cavity and no need of supports to make this printing possible. That's an idea. And then I will make some protrusion extra so that the cover what I make will go and settle on this surface. It will not protrude outside. It cannot be removed easily by anybody, and there will not be any chances of opening of this door by default. So whatever the top door will make with respect to this inner surfaces, and it will not be protruded outside. Later I made a cutout here to ensure that the threaded terminals should come outside, because we have very less length of thread in the potentiometer, so it is always important to maintain the wall thickness as required. I added a radius for easy printing, and then a bottom radius to add some good rigidity to the surface. Always adding a radius is always a good part to increase the strength. Yep. So this is how my assembly looks. Now I will show you my Arduino board mounting. So these points says about the Arduino board mounting. You can see the small protrusions which will hold the board on this position. Let's say from this surface to this surface it's a 5 mm, so the board will be hold on this 5 mm portion. It will not go down below this point. And you have protrusions here with the drafting as same as the DAV8825 board mounting. This looks good for me. There is no much effort is needed for this mountings. Okay. Let's see how the board assembly will be on. This is how it looks after assembly. The board will be mounted like this. Your USB connector will look outside like this. Your 12 volt DC is not needed here because power supply we are going to take from the same connector. This is DAV8825 extension board and DAV8825 assembled here. Then it comes top lid. Let's see how the top lid is made. Basically I took again the same kind of a rectangular box of the same dimension, the cutout made. I made round because to match with the box. I added some protrusion to make sure that this is not going to affect the Arduino board USB connector. Let me show you how it works in assembly. Let's take a cross section across this pin can see the USB point here. Model wise it will show like this, but practically it will touch the top surface, so that if you connect this USB cable, it will not go up or down, so it will be getting arrested in this portion. You will increase the robustness of this assembly. Okay, let's go back to the top lid design. I added a cutout for accessing this DRV8825 extension board for the motor cable, and I added some radius to avoid sharp edges and chamfers here to make sure it is not disturbing the potentiometer. Radius is added. Extrusion I have to add for making this magnets placement. I made buckets all over across the 4 corners for 10.2 mm diameter, and then the same concept of adding magnets as same as bottom box. And similarly I have closed this top layer so that the magnets will not be exposed outside. I added some extrude here to add some symbol for recognizing it is motor cables. I added some kind of symbol here. Let's see how it gets printed. So now this is how the final box looks like. When you see from the top, you will see the connectors here, and when you see from the front, you will see the USB connector for connecting with the Arduino. And these 2 holes, I have not made the model of a 12-volt connector and potentiometer here, but I know the practical dimensions. I measured the dimensions with the available components with me. The same is going to work for this. Yeah. So let's get this printed. Before that, we need to have this files in STL format to slice these files for 3D printing. Okay, let's save it as a save a copy stereolithography and give OK. I already generated these files, and let me show you how I am going to slice it. Now the improvised design is ready and it got printed. Now let's take them out from the bed. It's completely carbon fiber now without any dual color printing. Now I assembled all the boards inside, potentiometer and 12-volt DC connector in. Let's start wiring as per the schematics. If you have not watched the wiring schematics or don't know how to do the wiring, please refer the part 1 video of this. Improvised design is too rigid. When I assemble potentiometer, it's too rigid, and now the box is complete. Use the multimeter to check the continuity of plus and minus polarity. Make sure it is properly given. Now the wiring is complete. Let's give the power supply connection to the 12-volt to the 12-volt DC connector. I prefer to solder this potentiometer points and the 12 volt DC connector points. It's better to have some rigid connection like soldering, not like connecting some male female connectors. It's always advisable to do the soldering. Now the wiring is done completed. Let's make all the wires go inside the box. Before closing the top lid, let's connect the 12 volt supply from the SMPS and check the functioning is good. I find a problem. The power supply connector is not properly connected. Let me do some changes and then there is a loose connection with the 12 volt DC input connector. Let me correct them. Now the loose connection got rectified, and let's close the top lid and start the supply. Yes, now the motor started running as per the potentiometer input. I would like to add a knob for potentiometer stud. It's very difficult for me to handle inside. Let's adjust the wirings and properly close the top lid and add a knob for the potentiometer. Here it comes. After assembling the potentiometer knob, the complete module is ready for usage. If you want this module, you can text in WhatsApp number given in description below, or if you need the CAD files to get it 3D printed by your own, see the link attached in description. If you like this video, please do like and subscribe to my channel and comment your own designs, or let me know what designs you want to get 3D printed.